All right, so let's look at some questions from Unit 4 on your review for the final. So Unit 4 was on exponential functions and logarithms. And so let's get started. All right, so question number 1. The tuition at a public university was $40,000 in 2021. So I'm going to highlight that. That's an important value, $40,000. Between 2021 and 2023, which notice that is a 2-year interval. That's important. The tuition increased by 20%. So increased in 2 years by 20%. And since then, it has continued to grow exponentially. So in the same pattern, increasing by 20% every 2 years. Select all statements that describe the growth in tuition costs. So when I go through a select all type of problem, I kind of look at each answer choice as if it were a true false question. All right. So the first question, the tuition cost can be defined by the function c of y equals 40,000 times 1.20 to the y divided by 2, where y is the number of years since 2021. So this equation, that 40,000 should represent the initial amount, and see how that matches. 40,000, 40,000. And then the 1.20, it's increasing by 20%, then it's 100% plus 20% is what you're going to use for the factor. But this is in percent. So 120% as a decimal is 1.20. So that checks out. And then the last part of it is this y divided by 2 as the exponent. And I have to think about, does that mean because it's happening every 2 years, I have to divide y by 2? And so if we think about it, let's plug in like a 2. It has to happen in 2 years to increase by 20%. So if we put a 2 right here for y, well, 2 divided by 2 is 1, right? So in 2 years, it does increase by 20%. So this equation is the correct equation to use for this situation. For B, the tuition increased by 10% each year. So that would kind of make sense because half of 20% is 10%. Not sure if that's how it works. So what I'm going to do is I'm going to just kind of plug in 1 to see if that's what's happening. So for our factor, I'm going to just ignore the 40,000 for now because I'm really just looking to see the percent it's increasing by. So 1.20, if I do that for 1 year, then I'm raising it to the 1/2, replacing the y with a 1. And so when I put that into the into the calculator, 1.20 to the 1/2. So it's not quite 10%, right? It's like more like 9.5%. Oh my goodness. So not quite 10%, but the next question, this one would be true because when I put in a 1 year, I got 1.095, and that is increasing by 9.5%. If this decimal were to come over 2 places and go right there, to make it a percent, it would be 9.5% increase. Okay, next, the tuition cost roughly increases by a factor of 2.5 every 10 years. Oh, 2.5 every 10 years. So this time, I'm going to do this again, only replacing the y with a 10. So 1.20 to the 10 divided by 2. 1.20, oops, wrong button, to the 10 divided by 2. Oh, look at that, 2.488, which is about 2.5. So this was equal to 2.488, or about 2.5. And so I'm going to go ahead and circle answer choice D, because that is what happened when I put in this 10 for y, placing the y in the equation with a 10, and I got that value. And then finally, the tuition cost can be approximated by this function, where D represents the number of decades since 2021. So at first I thought this would be a correct answer choice because I also got the 2.5 in the problem above. And then I am actually not even the one that noticed it. One of my students noticed that this is not the correct starting amount. It's 45,000, not 40,000. So this is not a correct answer. So just A, C, and D there on number 1. All right, let's move on. Oh, now we're going to look at a YouTuber who's got canceled and their channel is losing subscriptions. Oh my goodness, at an alarming rate. The YouTuber's total subscriptions have a half-life of 3 days. Oh, half-life. Whenever you see that half-life, think to yourself, I am going to use 1/2 or 0.5 as the base of the exponent, because that's what a half-life is. Okay, so we know the half-life is 3 days, and then the YouTuber initially had 100 million subscribers. So initial amount is 100 million. So how many subscribers will they have after 3 days? So conveniently, 3 days is the length of one half-life, right? So it would be the 100 million times 1/2. There has been one half-life in a period of 3 days. So it's just 50 million. Okay, how about after 16 days? Well, same idea. I'm going to start with the 100 and then times 1/2. Now, 16 days is just over 5 half-lives because each half-life is 3 days. But I'm just going to write it as 16 divided by 3 because that is the length of a half-life. And so 100 times 1/2 to the 16 thirds, 2.48. So I would say 2.48 or about 2.5 million. Remember, these are still in millions. Okay. And now we're going to write a general equation using S for the number of subscriptions and D for the number of days, because again, the half-life is 3 days. Okay. So S, the initial amount was 100 million. It's a half-life. So the factor we're using is 1/2. And then it doesn't happen every day. It happens every 3 days. So we divide the variable by 3. Okay. All right. There we go for the first part of Unit 4. The second part of Unit 4 was all solving equations where we had something was unknown in the exponent. So that's when you were first introduced to logarithms. Okay. So our strategy to solve these is pretty consistent for every problem. The first thing we want to do always is to look, where is the exponent? It's right there. The base is 10. We always have to get that part by itself first. So in B, it's 10 to the m. To isolate that, in C, it's 2 to the k. Okay, so I want to get the base to the exponent all by itself first. This one is being multiplied by 9. So start by dividing by 9. And when we do that, we get 10 to the 2n is equal to 100, right? 900 divided by 9 is 100. And then this happens to be like a math fact. I know that 10 to the second is 100. So I'm going to say 10 to the 2n equals 10 to the second. So I just rewrote the 100 as 10 to the second. So now that the bases are the same, the exponents must be equal. So if 2n equals 2, then divide by 2, and n is equal to 1. All right, so sometimes it's just a math fact and you don't have to do, you don't have to use a logarithm to solve. So next one, the first step is still the same. I'm going to divide both sides by 6. 4,500 divided by 6 is 750. So 10 to some power is equal to 750. 750 is not a power of 10, and so I am going to have to use a logarithm. So what happens is the exponent comes down, and the base 10 is still the base of the log of 750. All right, so remember, whatever the base of the the base of the exponent is also the base of the logarithm. And now you can use a calculator. So your calculator is already programmed with log base 10. So when you just use the log button right here, it already knows you mean base 10, and then you type in 750. And it's about 2.88. So m is about 2.88. All right, next problem, same first step, divide by the 7. Divide by the 7. 112 divided by 7 is 16. I'm going to write it in the other direction. I like to have the variable on the left, so so these 7's divided out, right? So we have 2 to the k, and then equals 16. Okay, this is another time where this is a math fact, and so I know we kind of have two options here. I could go, 2 to the k equals 2 to the 16 as a power of 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 is equal to 2 to the 4th. And so right now I can see, then the exponents have to be equal since the bases are equal. Okay, so that's one option you could do there, is just knowing that the bases or that the exponents have to be equal, because you can write 16 as a power of 2. The other option is to use a logarithm. So again, our exponent comes down and it's equal to the log base 2 of 16. Okay, and a lot of you figured out in the calculator how to get logs to a different base. You just hit the math button and find the option for log base, and then fill in the spots. Log base 2 of 16 is 4. So either way, you get an answer of 4. Okay, so the strategy is up to you. All right, we have a few more. We have a different base this time, but we're going to kind of operate in the same way. So I have to get the base and the exponent on one side of the equation all by itself. So when our base is e, we still use the same, we operate in the same way. This is already isolated. X minus 5 is the exponent. We'll get to that one in a moment. And then over here on F, we have to isolate as our first step. Okay? So divide by 3, right? And 27 divided by 3 is 9. So we have e to the 4x equals 9. Okay? So again, our exponent comes down, and it's equal to the log base e of 9. Now, the log base e of 9, so that's actually called the natural log. So remember, your calculator also has that already programmed. So right under the log button is the natural log button. And so I'm going to use that to figure this out. So basically, I have to divide both sides by 4, right, to get x all by itself. And so rather than log base e of 9, I'm going to write the natural log of 9 and then divide the answer by 4. So back to the calculator. That up a little bit. The natural log of 9. And see how it opens a parenthesis. I need to close it and then divide by 4. There we go. About 0.55. So x is about 0.55. 0.55. All right, for E. So one of those things that you really have to remember is that any base to the power of 0 is equal to 1. So whenever we get an answer of 1 here, that means that e was raised to the 0 to get an answer of 1. Therefore, x minus 5 has to equal 0. So add the 5 over and you get x equals 5. Oh, I should have boxed this one. There we go. Okay, the last one on this page. So again, we have to isolate the base and exponent by dividing both sides of the equation by 200. And 10,000 divided by 200 is 50. So e to the 0.025t is equal to 50. All right, so we've got the base, we've got the exponent comes down, we switch to log form. So that whole exponent comes down, 0.025t. And then I'm just going to go ahead and write the natural log of 50. Natural log of 50. Again, it's natural log because the base is e. Okay, from here, to finally solve for t, just divide both sides of the equation by that 0.025 on both sides. So dividing here, they divide each other out, and we have t by itself, and then I have to use a calculator. So the natural log of 50, remember to close the parenthesis before dividing, divided by 0.025. Voila, 156.48. All right. Okay, so I think there's a few problems on the back side of this paper, just a couple. Okay, so this is a lovely problem about an expired loaf of bread with mold on it. The mold is growing exponentially, and here's the model. M of x is the total amount of mold covering the bread in square centimeters after x days. Okay, so a few things we need to know is we've got this equation, M of x equals 2 times e to the 0.088x. The amount of mold covering the bread in square centimeters after x days. So x represents the number of days. So question A, how much of the bread was covered when it was first found? And so this number before the base and exponent, that means the initial amount. So the initial amount is 2, and the measurements in square centimeters. So when it was first found, there were 2 square centimeters of the bread covered in mold. What does the 0.088 represent in this context? It represents that, remember it's called continuous growth factor. So it means that the mold is growing by, let's see here, if we move that decimal 2 places to make it a percent, 8.8%. Continues. Time to go home. Let's see here. How do I want to phrase this? I should have said the mold is continuously growing by 8.8% each day. Or, yeah. So I should have put the word continuously. Right there. Okay, so the mold is growing continuously by 8.8% each day. That's what that means. Write an expression for the number of days in which 8 square centimeters of bread will be covered in mold. Okay, so I can't start with that as an expression because I have to solve it. So I'm going to take the 2 times e to the 0.088x equals 8. But then actually to answer this question, I have to solve for x. Okay? So we start with 2 times e to the 0.088x equals 8. And then we solve it like we did all the problems on the page before. So we isolate the base and exponent by dividing both sides of the equation by 2. So those 2's cancel out, and I have e to the 0.088x equals 4. Okay, and just like on the other problems, now we bring the exponent down because the base and exponent are all by itself. So we bring the exponent down and switch to log form. So 0.088x equals, the base was e, so I will use natural log of 4. And then the expression for part C, the final answer for part C is just the expression. So to get x by itself, which is what it's asking us to do, you divide both sides of the equation by the 0.088. So x is equal to the natural log of 4 divided by 0.088. Okay, that is the final answer for part A. And then for part B, or they're not labeled, they're just the second part of C, I guess. Just put it into a calculator. So the natural log of 4, close the parenthesis, and then divide by 0.088. 15.75. 15.75. All right, so in 15.75 days, the bread will be covered in 8 square centimeters of mold. Lovely. Okay, so that is the end of Unit 4. Check back. I plan on making a video for each of the units, so hopefully I'll get them all done in a timely manner. All right, happy studying.